In this video, I'm solving a RLC series circuit. So here we have a R 42 ohm, L is a 3.6 millihenry, and C is 520 nanofarad. Those are the values, given values. Here he also gave us the maximum voltage, Vmax or V naught equal to 5.5 volt. Okay, and then he also gave us the frequency, which is 3 kilohertz. The question here he is asking about what is the instantaneous voltage when I equal to I naught. So when the current, instantaneous current equal to maximum current, what will be the instantaneous voltage? Okay, how do you find it? Why it is different value? Step 1, we always convert the given time domain circuit into frequency domain. That is nothing but we're going to convert inductance into inductive reactance, which is JXL, inductive reactance, and capacitance into capacitive reactance. So inductive reactance J omega L equal to J XL, which is J omega L. J omega is nothing but 2 pi f. So J 3.6 times 10 to the power of minus 3 times 3000 times 2 pi. So I found J omega L as J 67.85 ohm. That is inductive reactance. Same thing with capacitive reactance. JXC, this is always minus JXC. Minus JXC equal to minus J over omega C. I found that value is minus J 102 ohms. Now the total impedance G equal to R plus JXL minus JXC. So 42 plus J 67.85 minus J 102. So Z total equal to 42 minus J 34.15. That is in the rectangular format. Convert that into polar format. End up with 54.13 at an angle of minus 39.11. Okay, so I naught equal to V naught over Z total, which is 5.5 over 54.13. I mean I naught equal to V over Z total. So I end up with 0.1 at an angle of 39.11. So here you can see my voltage is right here, which is 5.5. That's the maximum voltage. Usually we indicate with RMS value. And the current is somewhere here, I naught, which is 0.1. The angle between these two is 39.11. Now this is positive angle. That means my current is leading the voltage by 39.11 degrees. So that indicates that when you draw it in a waveform right here, when you draw it in a waveform, my current is starting 39.11 degrees before than the voltage. So basically current is going to be maximum somewhere here. When the current is maximum, what is the voltage? That's what he's asking about. So this is the current I of t. This is the voltage V of t. So when the current is maximum, what is the voltage? So what I'm going to do, I'm going to write down this I of t in a sinusoidal waveform. You can write it down in cosinusoidal waveform. It's not going to make any difference. Okay. So I of t equal to 0.1 sine omega t plus 39.11 degrees. Now I'm going to substitute I of t equal to I max, which is I naught. So 0.1 equal to 0.1 sine omega t plus 39.11. So 1 equal to sine. So 0.1 cancel out. You will end up with 1. 1 equal to sine omega t plus 39.11. Now I converted sine inverse of 1, 90 degrees. Remember this omega is always in radians per second, but the 39.11 is in degrees. So you need to convert that into radians if needed. So I end up finding omega t value as 50.89 degrees. And from there I found the t value. So at 47.12 microseconds, I is going to reach the maximum value. At that point, what is the E naught? So I'm going to substitute this omega t value right here to find the instantaneous value. So I found that voltage as 4.267 volt. That is the first part. Now when it comes to the second part, he's also asking about what will be the E naught, or what will be the E value, voltage value, when I naught becomes 0 and going in the negative direction. So I naught becomes 0 and going into the negative direction is nothing but here, if you look at here, this is our current. This is our current. Whenever it reaches and it is going in the negative direction, what will be the voltage value, the voltage at this point? That's what he's asking for. So the current is 0 equal to I naught sine omega t plus 39.11. So I found omega t equal to minus 39.11. Now he clearly mentioned the voltage is going to be, the current is going to be negative. So that is the reason I added 180 degrees. So here minus 39.11 degrees, the current is going to start positive. Okay, but in the question he clearly mentioned the current is going to be negative after that. So that is the reason I added 180 degrees. So I end up with omega t equal to 140.89 degrees. So the voltage at that point is 3.46 volt. Okay, I'll stop this video here. In the next video I'll solve more examples. Thank you.